that era of transforming from like data centers to cloud, doing that whole digital transformation is sort of complete. I think most businesses, most industries that are very tech focused have actually done that. And now it's about moving and becoming a little more sustainable in the things we do. So really it's about measuring, it's about decarbonizing and doing that to all your products and operations. Now this has been in the consciousness for a while, but there have been few difficult questions about how you can actually do some of these things. And some questions have been hard to answer so far, especially in the context of technology. So things like, how do I identify a carbon emission hotspot with respect to tech? How do you reduce energy and water usage with respect to tech? Especially if you have your own data center back in the day. Really your focus is not on reducing energy and data, but just optimizing how you use it. And of course, that leads to things like how do you innovate faster and achieve this sustainability transformation. So today what I'm here to talk to you about is this idea of tech and sustainability and what you can do when it comes to architecting and building in the cloud and how that helps with this idea of sustainability. And for the reason about why we should do this, well, one, there's a small reason of the fact that we are saving the world. Kind of important. But also, I think as a business, it is a driver for growth in your business as well. There's this recent study by Accenture sometime last year, and they actually saw that companies that did digital technologies and sustainability and did that intersection saw like a 2.5x growth in what they were doing. So really, there is a business driver and a business use case to adopting sustainability. I think just from moving to like a old school enterprise data center to the cloud, we have typically seen an energy usage reduction by 80%. And this is because how the public cloud is structured. It is structured for shared resources. Right? And typically data centers use a lot more resources like energy, carbon, water, all that. And just by using the cloud, we are being a little more sustainable. But today we're going to talk about moving from that to actually architecting for sustainability. Okay, how many people here use AWS? I know a few at least for sure. Yeah. Okay, great. So if you have used AWS before, you might be familiar with something called the shared responsibility model. What this means is that when it comes to security and compliance in AWS, there is a shared responsibility between the customer and AWS for all things security. So AWS will take care of security in the cloud, or rather off the cloud. So things like your data centers are secured. It's not on like fault lines. It's blocked from any natural disasters. There is security outside. All the patches are done. All of that stuff. And at the same time, our customer takes care of the security in the cloud. Right? So they take care of all the compliance, and we give all the tools to actually make sure that things are compliant and secure. So when it comes to sustainability, it's the exact same model that we're looking at, which is the customer is responsible for sustainability in the cloud, and AWS is responsible for the sustainability of the cloud. So from an Amazon and AWS point of view, we take care of things like making sure that your servers use the least amount of energy, that water is locally sourced, it's recycled, it's cleaned, that the waste management is done, as sustainable as possible. And at the same time, we use building materials to really reduce carbon usage. So we are taking care of the sustainability of the cloud. But as a customer, you are responsible for the sustainability in the cloud itself. That's going to be the focus for today. So we talk about how data design, usage, storage, logs, all of that can actually be improved for you to meet your sustainability goals. Very quickly, let me give you some context about how AWS is looking at sustainability of the cloud. So, like I said, everything to do with all the data centers that AWS owns and operates, we are trying to make sure that we adhere to the climate pledge. And if you're not familiar with the climate pledge, this was signed in 2019, and essentially the idea is to be net zero carbon by 2040. The Paris Agreement was to do it by 2050, but Amazon and some other companies said, no, let's do it 10 years earlier, and let's pledge to do it by 2040. and also a path to 100% renewable energy by 2025. Okay, so this is a pledge that Amazon and few other companies have taken, and we're following it up with like very frequent reporting and metrics about how this process is going on. To go into specifics, I'd say these 6 things are the specifics about how AWS specifically is using it. For instance, when it comes to water in data centers, we make sure we use evaporative cooling, there is water management, and we use recycled water as much as possible within these data centers. At the same time, like I said, we use renewable energy, and by 2025, we're committing to using renewable energy 100% in the data centers. In terms of our hardware, we've switched a lot of our internal processes to Graviton 3. And Graviton 3 is an ARM-based process, and you actually see 60% reduction in energy costs. And just by doing that, we're able to see a reduction in carbon usage. And the last one I think is pretty interesting. It's called the Amazon Sustainability Data Initiative. And essentially, it's this really large data set that's completely open, completely free, and it provides things like satellite data and climate data for you to use at no cost. So if you're a scientist, if you're a researcher in that field, check it out. It's all online. You get access to these data sets that you can use for free. And lastly, we did join the Climate Neutral Data Center Pact. Again, this is a pact specifically in Europe. So just to make sure that all the data centers that we build are actually climate neutral, and other organizations are following up as well. So that was a very quick overview of the sustainability of the cloud. But today we're here to talk about actually architecting for it. So what changes can you do as technologists or as builders to achieve sustainability in the cloud? To really look at this is us to look at impact, goals, and metrics. Right? We all work in tech, and I'm sure we have like daily stand-ups, weekly calls, monthly reports, all of that. How many of you in your daily or weekly stand-ups actually have the word sustainability in that? Quick show of hands, anyone? Yeah? Yeah, I mean, a few years ago, we didn't, right? It's really not in our public or in our consciousness to think about it. We look at things like security and cost and efficiency for sure on a day-to-day basis. But for sustainability really to make any progress, it has to be part of our impact and our metrics. Really, sustainability in the cloud is a continuous, focused effort on energy reduction and efficiency across all components of a cloud workload. Right? And I know I've highlighted those words, but I think the key thing is the continuous focus. Right? Really integrating it into your daily, weekly processes and measuring it through metrics and goals. Yeah. So just to understand how goals and metrics work, they very often contradict or work against each other. So typically in the cloud, you'll be looking at things like storage, utilization, data transfer, and compute. There can be times when storage and data transfer work against each other, and you have to take a call as which one you want to optimize for in your workload. So you can say, look, I will store my data only in one AZ, but I'll move it around in different regions. So thereby your storage costs reduce, but your data transfer costs increase. Similarly, you can say, hey, you know what? I'm just going to compute data all the time and not store it. So then your storage cost reduces, but your compute cost increases. And these are calls that we make on a day-to-day basis when we look at cloud workloads. Essentially, sustainability is another impact goal, or it's a non-functional one. Right? It's a non-functional requirement, like things like cost, quality of result, availability, and response time. Again, these are some requirements that you probably talk about when you talk about your cloud workloads, and sustainability has to be part of those impact goals or those metrics. Again, very often they can work or they can compete with each other, right? And we're going to show you in a bit how it does so. But at sometimes increasing or saying being more sustainable might reduce cost, but it might change your availability. So really, it's about how you portray some of these things and really have it as part of your impact and your goals. If I have to summarize, right, if you really need goals for optimization, you really need to look at maximizing any utilization of cloud resources that you have and maximizing your CPU efficiency with very energy efficient design. Okay? You want to maximize your utilization. And while you're doing that, you really want to minimize or eliminate any resources that are idle, eliminate data processing that you don't really need, and the same with data storage that you don't really need. If you look at this slide, a lot of this also leads to lower costs. So in a way, it's a win-win. You're being more sustainable while typically reducing costs as well. The way to really look at how much resources you're consuming is not to look at an overall figure. Yeah? So for instance, if you're using like 50 virtual CPUs over a month, but say the number of users increase, that is not being efficient. Yeah? So really the way to look at this metric is look at resources per unit of work. So then you get an accurate, normalized sustainability KPI that can actually measure how you're doing in terms of what we saw in the previous slide. So for instance, you can look at, say, you're building an autonomous vehicle. So the number of CPU used per connected mile of a car, as opposed to just number of virtual CPU used, because again, that's not as accurate. From an AWS point of view, we released a service last year. It was a green light 2021, which allows you to actually see a very granular look at the carbon footprint that your cloud workload has. And it's called appropriately the customer carbon footprint tool. So if you use AWS, go into your cost, usage, and billing, you'll see reports like this. Right? You can actually see it broken down by service. So it says EC2, S3, and how many metric tons of carbon dioxide that particular service has used in a month, day, week, whatever. You can also see emissions per region. Right? You get very granular reports saying, okay, you're in North America, you have 74%, whereas in APAC and EMEA, it's a little lesser. And you also get like nice summaries about estimated carbon usage, what you will see in the future, and so on. Really, it is, like I said, having this as part of your metrics and goals matters a lot. So you get these reports in your AWS cost and usage report, and along with other metrics from your cloud workload, you can really build a case for business metrics, again, integrated into your day-to-day. And this is how you actually start the conversation about sustainability within an organization. In fact, at AWS, we've built it into this thing called the well-architected framework. Has anyone here used the well-architected framework? No? All right, so essentially the well-architected framework is a framework developed by AWS over the last few years to see if your architecture of your cloud workload is secure, is performant, has performance efficiency, is reliable, is cost optimal, and has operational excellence. We recommend that anyone doing a cloud workload go through this well-architected tool to make sure that their cloud workload is architected. And last year, we announced a new pillar to this, which is the sustainability pillar. Yeah? And as part of the pillar, there are five best practices, and that's what we will talk about today. So let's talk about actually architecting for sustainability in the lens of these things. Right? So we talk about how you can actually optimize when it comes to user behavior, when it comes to software and architecture, hardware, data, and deployment processes as well, starting with user behavior. I think it's really important in general to understand how, when, and where your users are. Right? And understanding that is the first step towards optimizing for sustainability. A key aspect here, like I've been mentioning, is the sort of service level agreements you have with your customers or your SLAs. Because based on your SLAs, you can architect and change different things to make sure that your workloads are actually sustainable. And this includes things like optimizing for where your users are, so in this case, geographic placement, or your team member resources as well. I'll give you a practical example. So this is, we're optimizing a workload and we're optimizing capacity for sustainability. Now we're going to assume that this is a mission critical workload, right? So we need immediate failover. And right now we're running in availability zone A. and availability zone B. But if there is some problem, we have to immediately fail over because we can't lose or risk losing our customer data. So right now you can see running in availability zone A, we have a utilization of about 50%, which is not great. And in availability zone B, we also have a utilization of 50%. Now, say that availability zone A goes down, you switch your entire workload to availability zone B, which is completely utilized. Now, this could be a sort of decent way of doing it, but you also have to run an availability zone C in case something goes wrong, which is not being utilized at all. Another way of actually looking at this is instead of running just in 2 availability zones to begin with, you can split it in 3 zones, but utilizing up to 2/3. Yeah? So instead of utilizing each at 50%, you're utilizing 2/3, but across 3 AZs. And if availability zone A goes down, you don't have to reserve as much capacity. Each of them can be split between availability zone B and C, and that way you're actually optimizing capacity for that, yeah, because your utilization here is close to 100%. So this way, again, you don't have a reserved capacity that's running doing nothing. If AZ goes down, AZA goes down, you can split your workloads evenly and have optimal utilization, right? But again, this depends on the SLA that you have with your customer. Say your SLA says that you don't need immediate failover. This is not a mission critical workload. It's okay if it goes down, you can take time for it to be back up. Then in that case, you can actually use old capacity for failover and optimize for resiliency instead. So in this case, you have availability zone A with full utilization, and you have an availability zone B as cold capacity just waiting there. If A goes down, it's cold storage, right? So you just use on-demand cold capacity to switch it over to the next AZ. Essentially, the idea is to negotiate SLAs that are impact friendly. And of course, we're talking about sustainability impact here. This can reduce cost, but you see small increases in response time perhaps, and of course, you see an overall reduction in impact when it comes to carbon usage. So we spoke about user behavior. Let's speak about software patterns, right? And sometimes in our hobby to build things, move fast, break things like that, we don't optimize software as much as we should be doing, even though it can, over periods of time, reduce costs and be more sustainable. You can do things like remove or refactor workload components with low impact. You can optimize areas of your code that actually consume your most resources as well. Let me give you a simple example. Scheduling, right? We all schedule workloads, and essentially you need reserved capacity for whatever you're running in the cloud. The thing we don't realize is we are reserving this capacity for the peaks, right? We're reserving that capacity in case those peaks are super high, even though the average is fairly low. What you have to realize is we actually end up provisioning capacity for those high peaks. But if you can find a way to reduce these peaks, you can provision much less capacity. If you see between the two slides, the average is exactly the same, but you've just distributed it a little more over a period of time. The peaks aren't as high, so the amount of provision capacity doesn't need to be as high as well. Again, reducing costs and reducing your carbon footprint too. Again, I'll give you a more specific example on this. Does anyone know what this is? If you're building things. This is like a cron table. Has anyone done like a cron job and scheduled it? You can specify like, okay, midnight, this day of the month, this day, whatever. And yeah, essentially it's a cron tab, which for the non-tech folks here, essentially you can run processes that are scheduled at a certain time. The thing we have seen is almost all of our customers choose to run it at midnight, right? For whatever reason, it's a common thing to do. You want to do something at the start of the day. And this ends up with a lot of clock synchronized jobs that actually drive up these peaks quite a bit. What you can, like I said, it really drives up the total AWS capacity used. What you can do is what we call reducing jitter, right? You're using offsets to change this time. It will have absolutely no impact on your cost because you're running the same job just at a different time. But because the cloud works with shared resources, you will actually see an increase in performance, possibly, while there's another reduction in overall impact, right? And you're actually seeing a drop in those peaks, so that's something you can do. All right, let's talk about hardware, and I think this is a simpler one to talk about, but essentially use the minimum amount of hardware really to meet your needs. One thing that we recommend, of course, because AWS offers it, is try and use managed services because performance efficiency is taken care of when you're using a managed service. At AWS, we launched Graviton a few years ago and Graviton 3 last year. And just by switching to a managed service which has Graviton, whether it's your database, your data analytics, or even your serverless components, you can actually see Graviton 3 based increases have 60% less energy for the same performance. So again, we're being a little more sustainable like that. All right, let's talk data patterns. All right, so this, I feel, is something that we all should be doing regardless, which is implementing data classification policies within your org. I think we've all heard the data is the new oil and how so much data is being generated by every business out there. But I feel as companies, we sometimes can be reckless with how we handle that data. We don't classify it accordingly, we retain it far too long, we don't delete data that doesn't need to be around. So really try and minimize all of that and also minimize data movement as well. Again, let me give you an example. Really classify your data between hot to cold. Hot data essentially is data that you're actively using that's being frequently accessed. Now, if you're storing it, you can store it in like an S3 standard bucket in multiple availability zones, so you have low latency for your users across the world. But for data that is slightly inactive, you can actually have second or millisecond access, but it doesn't have to be in every availability zone. And for data that is very infrequently accessed, you can put it in archive storage. That way, again, it's not being used too much, and you're reducing your costs too. From an AWS point of view, again, there is intelligent tiering. So AWS automatically classifies your data as frequent or infrequent access and puts it in different S3 buckets so that those cost savings and reduction in carbon footprint happens automatically. The same thing goes for EBS as well, block storage, so you can follow the same principles for EBS too. I think we generate a lot of log data when we're running cloud workloads or just building tech in general. And you'd be surprised as how much you can actually optimize log storage. For instance, at an internal team, we actually switched our compression algorithm for these logs. We switched it from gzip, which is a standard thing I think most of us use, to Z standard, which is a newer compression algorithm. And just by doing that, right, just by switching that compression algorithm, our compression ratio improved 30%, and we actually reduced storage by 1 EB. That's 1 exabyte. Does anyone know how many zeros in that? It's, I think, 1 billion GB, a really big hard disk, right? And only by changing our compression algorithm. So some of these small changes actually have a large downstream impact. So really think about how you can optimize log storage. Maybe there's some logs that are like more than 5 years old that you don't need anymore. Again, not part of your SLA, so throw it out. You don't need it anymore. And the ones that you do need, find ways to optimize it based on access and also, look at your compression algorithms as well. And lastly, let's talk about dev and deployment process. It's not only about your cloud workload. You want to look at things from end to end, and adopt methods and processes that allow you to bring in these changes and potential sustainability improvements over a period of time. This is something that's fairly new. We've just begun speaking about it. I think the consciousness about it has just started. So build out these processes that allow for future change. And Of course, when you're building end-to-end, increase utilization of that entire process end-to-end. One way to do that, of course, is by using managed services so that utilization is improved. Again, an example from AWS, but we actually managed to reduce our build artifact size, and we saw a huge improvement in how Carbon was used. So there was an SDK for JavaScript, essentially the AWS SDK. In the beginning, it used all of our services just built in. So when you added it to like your code, it actually enabled all of it. And then we converted it into like a modular SDK. So for instance, if you wanted to use just say Cognito and S3, you could include only those modules. And we actually saw, again, a huge reduction in the size of the SDK. We reduced our bundle size by 75%. And again, further optimization to that saw our publish size reduced by 50%. Very interesting blog post. You should read it about how they managed to reduce that build artifact by almost 75% just by making it more modular and giving devs the option of choosing what they want. Yeah, and just to sort of summarize what I just spoke about, when it comes to dev, look at things like optimizing your code, running more efficient, newer algorithms out there, and also reduce logging and reduce things like retries and work amplification. At the same time, in your ops, try and utilize all your resources better and try and automate as many things as you can because that leads to more efficiency in performance. Again, while you're doing all this, like I said, it has to make sense from an SLA point of view. So make sure that these savings in Carbon, in cost, are enough to justify the work and the effort that's actually being put in. Again, as a business, that's what everyone's going to look at first. In an ideal world, we'd be doing it, but this has to be done. So, that trade-off, again, is super important. So the reason I really wanted to talk about this here in the Netherlands is I think we come from a culture of sustainability. We've been harnessing wind power for many years. I just took this photo a few days ago. This photo actually is a bit of a cheat because that's a beer brewery and not a functioning windmill, but it's near where I live anyway. But yeah, we've been, for the longest time, have this culture of sustainability in the Netherlands. So I'm really looking at the builders here to sort of drive and talk about it even more. Right now, it's not a great scene overall in the world because greenhouse gas emissions are 50 gigatons of carbon dioxide, huge number. And ICT, or information and communication technology, might seem like a small bubble within that, right? But it is still a significant bubble. And like I said, tech is at the heart of everything that we do. So really, it's up to us to think just beyond IT and think beyond this bubble and look at incorporating sustainability into everything that we do. Some things as builders that we can actually do are things like this, which is set goals, ask questions at your workplace, but also start talking about it internally, externally, whatever, and bring it into that consciousness. I think it's something that is growing soon, so you will hear a lot from different companies, different products. So yeah, start that conversation. Anyway, hope you learned something new and hope this was fun. Feel free to contact me on LinkedIn, whatever. I'm here for questions as well. And yeah, enjoy the rest of the conference. Thank you.